Now it's time to deep dive into the agglomerative clustering or uh, bottom up method, bottom up way to create hierarchical clustering. So let's begin with the agglomerative clustering. As we have discussed earlier, the step one is to start with each data point as a separate cluster. That's what we want to start. So in agglomerative clustering, we will start with each data point as a separate cluster. Okay, that's what the step one. And let's take this is our data set x comma y. So you have x and you have y, two, and let's put that into, or you can just say two features you have, feature x and feature y. Let's convert this each row as a, let's take each row as a point 1, point 2, point 3, point 4, and then we will plot them on graph, because in agglomerative clustering the first step is considering each data point as a separate cluster. So P1 is one cluster, P2 is another cluster, P3 is another cluster, similarly P4, which is A7, which is 3 7, then P5 7 2, P6 9 7, P7 4 8, and P8 8 3, P9 1 4. So basically each data point will be considered as a separate cluster, and that's what is our step one. Then step two is to merge the closest pairs of clusters iteratively until all data points belong to a single cluster. So we will keep on merging the closest pairs of clusters iteratively until all data points belong to a cluster, and that's what we did it for left cluster, and that's what we did it for right cluster. Now what's next? So now the distances between clusters can be measured. So now you will find a cluster, you made a cluster, you have initially started with consideration or assumption saying that each data point is a separate cluster. Then you merge the closest pairs of clusters iteratively until all data points belong to a single cluster. But if you want to find the distance between clusters, so then to measure the distance between the clusters, we need to use methods such as complete linkage, single linkage, average linkage, or Ward's linkage. So what is that? That we are going to explore soon. Each and every measuring technique we can explore. But before that, let's take the same example and let's begin. So okay, so first let's create a data set. So now let's directly get into the action. So 2, which is hierarchical clustering. Out of that, the first one is agglomerative clustering, or we also call it as a bottom up. Okay, so let's take up a data set first. Okay, let me let me make up a data set. So let me import numpy and numerical python as np. So at this moment, so that's what is enough for me. Okay, so let me go down and let me make my data set. So this I require a two-dimensional array. So I'm checking this two-dimensional array. And if you want to see my data set, so if name is equal to main, so that I can do the self-testing here. So let me print x1 and execute it, and this is what is our data set. If you have any doubt, you can explore more about this. Print x1 dot n dimensions, and here you can see it's a two-dimensional data set, and if you want to see more still you can do that. And print two-dimensional n dimensional, then size, it's 18, the data set is 18. And shape, if you want to see the shape, and here it is, it's 9, dimension 1 is 9, so basically here 9 rows and 2 columns, that's what it's saying, 9 rows and 2 columns. And this is all about our data set. Okay, now let's get back to the action. So now let's move on further. So let's look into the steps for agglomerative clustering in totality. So first one, step one, compute the proximity matrix using a particular distance metric. That could be an Euclidean distance or Manhattan distance. Then once that is done, each data point should be assigned to a cluster. So we have to consider each data point as a cluster. Then merge the clusters based on a metric for the similarity between the clusters. Then update the distance matrix. And final one, the final step, repeat step 3 and step 4 until only a single cluster remains. So finally, the first step, let's begin with the first step. Let's deep dive into the each and every step. Obviously we have gathered our data set. Now it's time to deep dive into the each and every single step of the agglomerative clustering. So step one is to compute the proximity matrix using a particular distance metric. So computing a proximity matrix, and this is how it looks. We'll take a P1 point and P2 point. We'll take P1 point and both the points, and we will calculate the distance between each and every point. Okay, P1, 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 P2, every point. You can see the combinations basically on your screen. You can see the permutations basically on your screen, and you have to calculate the distance between each permutation, and you can, with that you can make a proximity matrix. So the first step of the algorithm is to create a distance matrix. The values of the matrix are calculated by applying a distance function between each pair of objects. The Euclidean distance function is commonly used for this operation. The structure of the proximity matrix will be as shown above, with n elements, and here d of pi, that's pi comma pj, represents the distance values between pi and pj. So let's uh, write some code for the same. So now anyhow, our data set is ready. Now let's try to visualize our data set. Obviously, if you want to visualize, we need to have some visualization tools or libraries. Let me bring them. So import matplotlib.pyplot as plt, and let me import seaborn as sns. Okay, so now let me create a subplot. Okay, plt create a subplot fig comma ax is equal to plt dot subplots, and the size is okay. Let me check. That's it. This is your subplot. Now it's time to create a scatter plot of the above data. So let me say ax dot scatter, and inside I need to provide the respective data set. Okay, then x1 1 sorry. Okay, so and the color that I'm gonna go for, C, that's okay, that's fine. And let me execute it. And this is what the color we have gone for is a red color, and here you can find out that's how our data set has been distributed. You can see that. This is how it looks when we put it on scatter plot. Okay, now let's create numbered labels for each point. Let's create a numbered labels for each point. For I in range, x1 dot shape 0, basically the initial. So then let's go for annotate. So ax dot annotate, and string of I xy is equal to x1 of I comma 0, and other one x1 of I comma 1, and xy text is equal to 3 comma 3. Then let's go for the text coordinates is equal to offset points. Okay, so that's it. Let's put back respective labels, title, limitations, and everything. So x dot x label, set x label, which is x coordinate. Let me say x axis, and ax dot set y label. Let me say y axis, and ax dot title scatter plot of the data. Then ax dot set x limitation or x limit. So let me set it from 0 to 10. Okay, then ax dot set x ticks. So let me put range of 10. PLT dot, then let me go for ex dot set underscore y ticks, again a range of 10. And that's it. Now it's time to say PLT dot show. So this is what scatter plot, and these are the points, respective points that we have here. Okay, 0, 1, 2, 3, 4, 5, 6, 7, and this is how our data set, the annotation has been done for the respective data points, and that you can clearly see on your screen. Here it is. Okay, so now let's move ahead. So now, so we have completed two steps, which is step 1, compute the proximity matrix using particular distance matrix, and step 2, each data point is assigned to a cluster. Okay, so we have to assign each data point to a cluster. Let's do that. So this is our data set, and these are our data points, and each data point should be assigned as a cluster, and that's what we did. Even if you see in our scatter plot that we made in Jupyter Notebook, so it's like we have assigned each data point as a cluster, and that you can see here clearly on your screen. Cluster 0, cluster 1, 2, 3, 4, 5, 6, 7, 8. 8. So total these many clusters we have at this moment. So so this, till this point we have done it. So you can see that a numerical example will help illustrate the methods and choices. We'll use a small sample data set containing just 9 two-dimensional points that is displayed here, and that's what we have shown here. So 9 two-dimensional points has been displayed here, and each point we have considered as a cluster. So that's the next step that we can see here. So now what's next? So we have done with step 1, which is computing the proximity matrix using a particular distance metric, and second point, each data point should be assigned to a cluster. That is also done. Now the third step is to merge the clusters based on a metric for the similarity between the clusters. Again, I'm repeating, the third step is to merge the clusters based on a metric for the similarity between the clusters. Suppose we have two clusters in the sample data set as shown in the figure. There are different approaches to calculate the distance between the clusters. So now we are inside the third step. Now to do the third step, we can use different approaches, basically different approaches to calculate the distance between the clusters. So popular methods are min or single linkage, max or complete linkage, or centroid linkage, or average linkage, and word linkage. So these are the different approaches that we can use to calculate the distance between the clusters. So obviously initially each data point is a cluster. So P1 is a cluster, P2 is a cluster. So now you need to find the distance between the each cluster. So after that you have to minimize. So then once it is done, once you have calculated the distances, then you have to merge the clusters based on a metric for the similarity between the clusters, between the clusters. You will see the similarity in between the clusters, and you will merge based on that. So that's the step 3. For the step 3, to achieve the step 3, we can use the following respective approaches. However, we will begin with the first approach, known as min linkage. Okay, min linkage. So we will be doing a min linkage now. So in min linkage, what we're going to do is, one way to measure the distance between the clusters is to find the minimum distance between points in those clusters. So that's, we can find the point in the first cluster nearest to a point in the other cluster and calculate the distance between those those points. So basically you have to find a single linkage, a minimum single linkage. Okay, obviously you have to find the points of the clusters where the distance is minimum. That's what. And if you see in this example, P2 and P5, the closest points are in one cluster and in other. The distance between those points, and hence the distance between the clusters, is found distance d of P2 comma P5 is equal to 4. But when you compare the distances between the other points, it is higher. So the advantage of the min method is that it can accurately handle non-elliptical shapes. The disadvantages are that it is sensitive to noise and outliers. Anyway, let's explore the first approach to merge the clusters using a min or single linkage metric for the similarity between the clusters. Okay, so now it's for that we need to import respective modules from the respective libraries and package. So I'm gonna go for the SciPy. From SciPy, which is a scientific Python, SciPy, I'll take up the cluster scipy.cluster and hierarchy package, and from there I'm gonna import two modules. One is dendrogram. One is from scipy cluster hierarchy. I just want to import dendrogram comma linkage. Okay, so this one, the import has been done. Now it's time to create a first it's time to use our first method. Obviously a metric, the distance calculation we will do with the Euclidean, but the method, the approach, I want to use the minimum or single linkage or min linkage approach. Linkage approach. I want to find out the minimum distance points based on that. So the first one is to measure the distance between clusters. Obviously, to measure the distance, you can use either Euclidean or Manhattan. Okay, but the approach that we are going here is uh, uh, the min linkage. Okay, min linkage, the distance between in this, we have to find a points where the distance is a minimum. That's what we are gonna do here. So it's a min, or you can say single linkage method or approach for hierarchical clustering and specifically agglomerative clustering. So let me say this as min linkage which is equal to, obviously I have to call up the linkage method or linkage function, and inside the linkage function I'm going to use our data set. That's the first argument I have to provide. Then I'm gonna give the method, and in methods we have single, complete, average, word. I'm gonna go with the single method single. Then metric, I'm gonna go for the Euclidean. Okay, so this is what is our min linkage so approach. So these are the respective arguments you should give to create agglomerative clustering, to make agglomerative clustering. So now let's try to visualize the same. So for that I need to create a dendrogram. Okay, so let me create one more figure. So let me create dendrograms for that. So fig 2 and x2 is equal to plt dot subplots, and let me go for the 2 by 2. Yep, so we got the 2 by 2 here. Here you can see that 2 by 2, and the first one I'm gonna go for the min linkage. So x2 is equal to x2 dot subplots. Let me go x2 dot or else let me do it in other way around. Let's create, okay, so let's do the plt dot figure, and I'm going to go for the fig size a tuple 15 to 10, and plt dot subplots, directly I'm going to use second method of matplotlib. There are two methods, one is explicit and the other one is implicit. Okay, so explicit, and here we can use implicit method. So subplots 2 comma 2 comma 1, and dendro, so data set is min linkage. Let me plot it. So let me say the title, let me give the title for this. Title for this is single or min linkage, and let me execute it. There is an issue here. Yep. Okay, got it. And here is your a single or min linkage plot or dendrogram, and this is how total we have 9 clusters, and this 9 clusters has been made into these many clusters, and that you can see. So this is 1, and this is 1, and this portion is 1. You can clearly make out. Okay, so this is how we use a single or min linkage approach or method using Euclidean distance metric to create agglomerative hierarchical clustering